Relational data modeling. In the previous chapter, we described conceptual database design using object-based entity relationship or ER data modeling. In this video, we will discuss the logical database design. The objective of a logical database design is to transform the conceptual data model into a set of relations used for physical database design. We describe logical database design using record-based logical or relational data modeling, which is widely used in contemporary database applications, and a general modeling approach. In this video, we will cover the following. Describe relational data model. Describe relation, attribute, and record. Explain properties of a relation. Describe relational keys. Describe integrity constraints. And describe how to transform ER to relations. First, introduce. Relational data model was first introduced by IBM's EFCOD in the 1970s based on mathematical concept of a relation. Physically represented as a relation or a table that stores data. It consists of three components: relational data structure, where data is organized. Second, data manipulation, which consists of operations used to manipulate data stored in the data structure. Third, relational data integrity, which are the rules that maintain the integrity of data when manipulated. A relation is the main data structure that stores and organizes data in the relational data model, two-dimensional grid that holds data about the object in the database. This diagram shows an example of the ER diagram and the relational schema of the student relation. A column of a relation is referred to as an attribute. The number of attributes in a relation is called the degree of the relation. A row is referred to as a record. The number of records in a relation is defined as the cardinality of the relation. Next, let's discuss the properties of a relation. Each relation is uniquely identified by its name. As you can observe here, each relation has its own name. Second, each cell of a relation contains exactly one atomic value. That is, there should only be one value in each cells. Third, each record of a relation is unique. There should be no duplicate records in a relation. Fourth, each attribute in a relation has a distinct name. The values of an attribute are from the same domain. For example, the participant ID has the same domain, which is consisting of integer values, while the name has the same domain, which is a string data type. The address is a combination of numbers and strings. The order of the attributes is irrelevant. And lastly, the order of records is also irrelevant. Data manipulation is our way to access and manipulate the data in the relations. It is done using a data manipulation language such as the structured query language or SQL. Here is an example of an SQL statement. Update TBL faculty set salary equals salary times 1.05, where join date is less than January 1, 1995 and salary is less than 70,000. Relational keys. We need to specify one or more attributes or relational keys that uniquely identify each record in a relation. One of the relational keys is called the superkey. It is a set of one or more attributes that uniquely identifies each record in a relation. A candidate key is a minimal superkey, one that has a minimum number of attributes. A primary key is a candidate key that has been selected to uniquely identify records in a relation. In selecting primary key, we need to consider the following. It must be unique within its domain at all times. The candidate key can never change, and it cannot hold a null value. A composite key is a key that has more than one attribute. Foreign key. A foreign key is an attribute or a set of attributes in a relation that serves as a primary key of the same or some other relation. Here, in this example, we can see that the student relation has the foreign key department name. Department name here is a foreign key because its existence is from the department table. And in that department table, the department name is the primary key. About null. Situations where attribute cannot be assigned with a data value. There is no applicable data value, or when the value is unknown, we have to assign null. Assign null value in these situations. Null means that the value is either unknown or not applicable. Null is not the same as zero or white space. Integrity constraints. There are three types of data integrity constraints: the domain constraints, the entity constraints, and the referential constraints. Let's talk about the first, which is the domain constraints. A domain is the set of values that can be assigned to an attribute. For example, if you have the attribute SSN, its domain name is SSNs. The description is it is the set of all possible SSN values. The domain is the number, and it has the size of 9, and the format is shown in the slide. The domain constraint states that all the values of an attribute must be from the same domain. So for example, since the domain of SSN is number, you cannot enter a string or a character to the SSN attribute. That will violate the domain integrity constraint. Second is the entity constraints. Entity constraints ensure that every relation of a relational data model has a primary key and that the value of the primary key cannot be null. If the primary key it's the minimal set of attributes that uniquely identify your records. Second, say the primary key can have nulls. We don't need all attributes of a primary key to identify the tuples uniquely or the records. And that is a contradiction. So that is why there should be no null for all your primary keys. Third integrity constraint is referential constraint. A referential integrity constraint ensures that the foreign key values of a relation must come from the primary key values of the related relation. Otherwise, the value of a foreign key must be null. Here in this example, we have the student relation and the department relation. In the student relation, we have the department name, foreign key. So, the referential integrity constraints states that all values that you should include in the department name foreign key must come from the department name primary key, which is from the department relation. Now, if you enter a department name, let's say BME, and BME is not included in the original department table, then that is a violation of a referential integrity constraint. The representation of referential constraints is shown in this illustration. You add an arrow starting from the foreign key attribute pointing to the associated primary key attribute. Next, how do we transform our ER diagram into relations? You need to follow these rules or step-by-step guide in transforming your ER diagrams to relational model. First example is, how do we transform regular entities? First step is you transform the regular entity in an ER diagram into a relation. Let's take a look at the ER diagram student here. As shown, the student entity becomes the student table. The name of the entity will become the name of your relation. That is, in this example, student. Number 2, assign the entity name in an ER diagram as a relation name. Number 3, make each simple attribute of a regular entity an attribute of a relation. As we can see, the attribute in our regular entities are SSN, name, email, and phone. These 4 attributes becomes the attribute of your relation, or the columns of the relation student. So the relation student now has the following columns: SSN, name, email, and phone. 4. Make the identifier of the regular entity type the primary key of a relation. Here we just copy the SSN as the primary key. Second example, if there is a composite attribute, how will you transform it into your relation? The first step is you include all the simple attributes of a composite attribute in the relation. In this example, the address is the composite attribute and it is divided into simple attributes which are street, city, state, and zip. So those 4 simple attributes are included in our student relation. The address is not anymore included. Third example is if you transform a multi-valued attributes. First step is you transform a regular entity as described. However, do not add any multi-valued attributes to the relation. Second, create a new relation, one for each multi-valued attribute. The new relation should have 2 attributes: the identifier, or the primary key of the regular entity, and the multi-valued attribute. The name of the new relation should be a logical name that reflects the meaning of a multi-valued attribute. Third step is the primary key of a new relation is a composite key. The 2 attributes of a new relation together serve as its primary key. Let's take a look at an example. Here we have the student relation and it has an attribute skill which is a multi-valued attribute. Now, what we gonna do here is that we create the relation student, and then we copy the simple attributes, which are SSN, name, email, and phone. Now, for the multi-value attribute, you have to create a new table. The name of the table here is student-skills, which pertains to the attribute skills of the relation student. Now, what are the attributes that you will put in your second table? Those are the primary key SSN and the name of your multi-valued attribute, which is skill. And these two will be your primary keys in the second table. Again, the second table, student skills, will have the primary keys SSN and skill. When the primary key is composed of two or more attributes, it is called composite key. Example number 4 is if you have a one-to-many unary relationships. First step is you transform the entity of a unary relationship as a regular entity as described previously. Second, add a new attribute, primary key, of the same relation as a foreign key. Draw an arrow that originates from the foreign key and points towards the primary key. Here is an example of a relation in a unary or a one-to-many unary relationship. So, in a one-to-many unary relationship, there is only one entity. So, we have here one relation. So, again, when we say relation, that is, in simple terms, that is also called table. So, here in our student table, you have student ID, name, email, and phone. And then we add a foreign key. Because this is a one-to-many unary relationship, the guide says that you will add a foreign key. This one, the foreign key name represents the relationship of the unary relationship. Here, this is called student rep. And then you should draw an arrow from student rep pointing to student ID. This means that the student rep's value must come from the student ID. This is the actual ER diagram in the example shown in the previous slide. So this is a one-to-many unary relationship which includes the student entity and the student, and this means that the student represents another student, or one student represents many students. So as you can see, we copy the simple attributes student ID, name, email, and phone. And then for the relationship, we have to add a foreign key. That is, now we call it the student rep. Next example is many-to-many unary relationships. If it's unary relationship and it's many-to-many, we follow the following guide. First, transform the entity of a unary relationship as a regular entity. Create and name a new relation to represent the many-to-many relationship. Third, the new relation gets the primary key of the entity and the second attribute representing the many-to-many relationship. The primary key of the new relation is a composite key of the two foreign keys. Then draw differential integrity arrows for the foreign keys. Next, add any attributes of the many-to-many relationship in the new relation. Let's take a look at this example. We have the item, um, entity, and this ERD shows a unary relationship and it's many to many. That means one item contains many items, or one item is composed of many items. So here we copy the item entity, it becomes the item table, and we copy the attributes, which are the simple attributes item number, name, cost, and location. Next, for the relationship, we will add a new table. Here, the new table consists of the primary key item number and the component key, which represents the relationship of the two items. And then we copy the attribute of the relationship, which is the quantity. The primary keys of the second table should be the primary key of the item, which is item number, and another primary key, which is the attribute you included that will represent the relationship of the two items. And in this case, that is component number. And then we draw arrows from item number to item number and component number to item number. This means that the values that we will assign to item number and component number must exist in the original table, which is from the item number of the item relation. This shows the relation of the ER diagram that we showed in the previous slide. Here, the relation item and the new relation component after transformation. So you might ask, how do you decide what to name your second relation? So it is up to you, and it should be related to the relationship of the items. This time we can name this component because an item contains many items, so that means the other item is a component of the item. Another example is if it is one-to-one binary relationship. These are the guide. First, create two relations, one for each entity. Transform each entity into a relation as a regular entity. Second, include the primary key of one relation as a foreign key to the other relation. The mandatory side migrates towards the optional side. 3. Show the referential integrity constraint by showing the arrow diagram. 4. Any attributes on the relationship along with the foreign key migrate toward the optional side of the relation. For example, we have the employee assigned to workstation ER diagram. So the employee here has an optional side and the workstation is the mandatory side. So this is binary and it's one-to-one. So the first thing is we have to copy the employee table and its properties or its attributes: employee ID, name, designation, and office. For the workstation, we have copied comp ID, disk space, speed, and system. And for us to illustrate the relationship, we have to create the foreign key. So the assigned to and the date. So to show the relationship, we will add the primary key of workstation. Why workstation? Because the workstation has a mandatory cardinality. So whichever is the mandatory, the primary key of that relation migrates to the other relation. It becomes a foreign key. So here, the workstation is mandatory its primary key is computer ID. So we create computer ID as a foreign key, and we include that in the employee relation, as well as the date, which is the attribute of the relationship. So again, we add the foreign key, computer ID, and the attribute of the relationship, which is date. So we add the computer ID and the date to the employee relation because the employee has the optional side. So the guide says that we will add the foreign key to the optional side. In the ER diagram, the optional is the employee. So this table shows the relations and its data in our previous slide. Next, example if there is a one-to-many binary relationship. We need to follow the following guide. First, create two relations, one for each entity. Transform each entity into a relation as a regular entity. Second, the primary key of a relation on the one side of a relationship migrates towards the relation on the many side of the relationship. It is you should show the referential integrity constraints. Third, any attributes on the relationship along with the foreign key migrate toward the relation on the many side of the relationship. Let's take a look at our example ERD. This is a one-to-many binary relationship. The student belongs to department. So the student belongs to only one department, and one department has many students. So the many side is the student and the one side is the department. If it's one to many, you have to migrate the foreign key to the many side. Okay, so that is why first we copy the student and then its properties or attributes are SSN, name, and email. And then we add the foreign key to the student because the student is the many side. So we add the foreign key department name, which is the primary key of the other table. We also add the attribute joining date, which is the attribute of the relationship. And for the department, we just simply copy all of its attributes, which are department name, address, and phone. Next example is if it's many-to-many binary relationships. First, we create two relations, one for each entity. Second, create a third new relation to represent the many-to-many relationship. Third, primary key from both the relations migrates to the new relation. Fourth, show referential integrity constraints. 5. Primary key of the new relation is a composite key with foreign keys of relations. 6. Any attributes of the relationship migrate toward the intermediate relation. Example, this is the many-to-many binary relationship. Employee, assignment, and the project. So this means that one employee is assigned to many projects, and one project can have many employees assigned to it. So we have first to copy the employee and its attributes, EID, name, department, and designation. Next, for the project, we have the PID, the name, the location, and the duration. Next, because this is a many-to-many, you have to add a new relation. And this time, the new relation is assignment. Now, what you will add to the columns of the assignment are the primary keys of the two relations, which are EID and PID. And then you have to add the attribute of the relationship, which is the date. Next, transform ternary relationships. We have to follow the following guidelines. First, create 3 relations, one for each entity in a ternary relationship. Second, create a 4th relation that represents the ternary relationship. 3. Primary key from the first 3 relations migrates to the new relations. 4. Show referential integrity constraints. 5. The 3 foreign keys of the new relation together serve as a composite primary key. 6. Any attributes of the relationship migrate toward the intermediate relation. Example is the participant, court, and tournament. This is a ternary relationship because there are 3 entities in one relationship. Now, we create relations for each entity. We have the participant, the tournament, and the court. So the participant has the participant ID, name, and address. The tournament has the tournament ID, name, location, and number of times per year. For the court, we have the court ID, court type, and capacity. If it's ternary, you have to add a new relation. So this one, the new relation represents the relationship. So here we have the match. This is the new relation, the match relation. And its primary key are its primary key is the match ID. And then you add the foreign keys, participant ID, tournament ID, and the court ID. And then you add the attributes of the relationship, which are the time and the date. This one shows the example data of the 4 relations in the previous example.